Eric Burgess here. A loaded die has the probability of getting a 1, 2, 3, 4, 5, or 6 as a half, a sixth, a twelfth, a twelfth, a twelfth, a twelfth. Create the probability distribution table. So a loaded die, if you're unfamiliar with the term, it just means that a die that has unequal probabilities of getting the various sides. So maybe there's a weight inside of it that throws off the probabilities. So the probability table, right, is going to look something like this. You're going to have a line. On the top, we're going to have the event x, which would be the various numbers. And on the bottom, we're going to have the probability p of x, which is the probability that the event happens. So we've got the events 1, 2, 3, 4, 5, and 6. And we've got our probabilities listed right there. So we're assuming they like correspond, right? The first one goes with the first one, the next one goes with the next one. So the probability of getting a 1, right? That's a 50-50 chance, 1/2. Probability of getting a 2, that's a sixth. Probability of getting a 3 is a 12th, and the rest of them are 12ths, right? We have 4 12ths. And this is the probability distribution table. So this is typically how we'd write it. It's a pretty easy table to look at and quickly find what the probability is. So if someone said, they gave you a table and they said, what's the chance you get a 5? You'd say, oh, a 1/12th chance. Or the chance you get a 1, you get a 1/2 chance. And right now it's really obvious because we just made the table and the way the question's phrased. But I've seen students accidentally think they have to do a whole bunch of extra stuff in order to get the probability given this table. When really you just have to look at it and write down, what the number underneath it is. So just be aware. It really is just that straightforward. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.